so neat and tidy. So in this video, I'm going to share some tips and tricks that I use in my breadboard projects. And first of all, remember that the primary purpose of breadboarding is experimentation.
Well, GPT-3 don't like what I'm doing. I angered the volcano on Iceland. Alright, what are you doing? Did I press button and not realize it? Do stuff. Come on. Brandon, there we go.
So I would actually encourage you not to make things too neat when you're first trying to get something.
All this is this right here. I know it doesn't seem like it. Brownie Factory, breadboard, 2 pounds of wheat, 2 pounds of barley. We got inside of here some genesis of this. I mean, firstly it started as this, not this. This became useful about most of these coming into all this. I mean, just numbers of cuneiform into little, okay, zeros in one. I had a space and I had a thing, and that space didn't mean a damn thing at any point in time.
For example, you wanted to be easy to try out different component values and make other changes to be able to quickly see what the effects are.
You got to get that part to beat the singularity to go faster than geodesics. Then I know resistors do an LED.
You still may not necessarily want to do anything else with the breadboard. Often at this point,
I'll be coming back and watching this one tonight.
I encourage you not to make things too neat when you're first trying to get something to work.
See, like, how do you know? There's numbers already. You violated the rules of physics, my friend. This is where it comes up. Well, you are here, and every time you do something here, that'll turn into a hot mess about all kinds of crazy. We're going to get into that. As this does, this chip builds, see, I already don't even know what the hell this is. I have no clue. I mean, this is a wire. It's a loopy kind of ones and zeros between 1, 1, 1, 1. This thing pumps out 8, right? That's on a hex code, but this thing, you know, in terms of what it is, this got 8, you know, so this is your first bit to hexes to do things, so I can get those things to program A0, A1, A2, and vector positions. And because of all this shit, you would think it would be nice and organized, but somebody's like, no, I'm going to do it like this. And for some fancy magic on the standard model, all that, back to the stone mill, you're going to get into all this hot mess. There's the guillotine I'm running rocking through. Beep, beep, meow.
And, you know, I always recommend starting with high quality.
And on the piece of paper.
Especially true if you're building something semi-permanent, because you don't want the contacts to stretch out over time.
Your breadboard. You pumping energy through it up here. I mean, it follows some basic rules. If you're Japanese, you're going to do it on the standard model the other way. Or, well, all right, wait a minute. Hold on, move this page. And then, now we're good. That's pretty much it. You know, but basically for lines of code on here, that's how it works. But this thing does something independently already. I mean, the code being right here, something very small in the heading on what that is. So many words and stacked in theory. Everybody did. Everybody. So in through those pipes, through different gauges, or if the circuitry was something different, I'll get to this result. Superposition relative to each other on lensings, the stack, how many rocks will get there for timelines, is the appropriation on the app on.
What you want is you want it so that when you put the wire in there and squeeze,
basically it's still
it doesn't nick
still running.
Click, 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 click.
Now you can make a loop do this. You can, so it'll.
And I'll talk a little bit more about why.
Why?
You can also get it with.
This is why.
You'll sometimes see it like this, where you have this nut that you can move back and forth, which is.
I know it doesn't seem like it. You can touch it, but no.
Although this one seems to work for me. But whatever.
Well, it's a force. If it gives off light and you can hook up on it, if it gives off space, and you figured that out, and it plays the same damn rules as this here on all the go away versions instead of come here versions, well, then you figured that out. And you started from here though, and you inverted those off first.
You want something that's just kind of small and can get in there. And then same thing with the needle nose pliers. You want these to be nice
this could be this. This could be. I mean, you got headblades, pliers. Okay, we're good. This one's over here. I've been here before. Okay, that's based off of this move over here. We're not quite sure what the ones and zero, but they went ballistic over here, and that's a good thing. Or they stabilized, and whichever version of this I'm looking for right at the moment, and that's back to
so let's start wiring some stuff up.
Photons.
I'll start with this wire here. We've got a wire that's going from pin 3 of the 5.5 timer over to the LED here.
See what you make me do, Sharps? He was fine. He was doing stuff. I left him alone on the farm for a little while. I come back and he had all this shit built and I needed it, and then I had to come figure it out. I will find you. I'll get you back.
What I'll do is I'll bend this 90 degrees, and I use the needle nose pliers for that.
Carry right along.
Bend it like that.
That's all.
Then I got a nice 90-degree bend there. You can see.
Brownie Factory is that guy clocked in here. Well, he moved in. He got in here, all American. So I was like, game theory, we'll see how this plays. He's like, bang, and some knights on the table. I had hands. Now we're figuring out what's left and how they play. There's one of those boxes right here, MiG 1 to MiG 2.
And the way I do that is I take advantage of the fact that the amount
you know, then you're building into some. Did you see that? Did you do that where you put a resistor here and here and then test it and look at it, or did you just skip through all those steps and was like, oh, I'll figure it out from here? Ah, well, there's actually a whole damn standard model.
Because it turns out that the holes on the breadboard are 0.1 inch apart. So if we measure 0.3 inches is 3 holes.
5 minutes from midnight every time. Damn downpour.
We put this back where
I see it. I see the map. Wait a minute.
The other end.
Where is it? There we go. All right, we're here.
And if I count 3 holes past where it goes,
now you did the right things here.
It's going to end there.
Do it right there.
1, 2, 3,
little. You can design it any way you want. You can come over here and you can make it do these versions, the output versions like this, or you can do the stone mill on axes, so then it does 3D kind of versions where you can click on it and get into the skid steer 300 IQ models.
Now what I need to do is strip off the other end. And I need to strip off 0.3
breadboard.
inches.
Okay, I'm here.
And
where am I going tomorrow? This is going to be pretty important. I mean, for some people, that equation is like, oh, no. The whole reason, the capstone first, do the end of it to begin with on zeros and ones because it has to know that about the first move on a thing before it can do anything. And this is going to be a better find somewhere because stone. I mean, it's not that it's not there. It's not that I couldn't find it. I will find you. Yeah, Stanford force bar inside here. I mean, it starts on a turbulent flow this way, and it did an angle. It did this, and went hot or cold or high or low, excuse me. You know, on the things, and that makes ones and zeros on this thing do something different because you tested them. And you know, not only that one, but when you change that wire around, because you're like, oh no, go back.